Hello and welcome to Taritam AI. In this section, we are going to cover binning as the data pre-processing part of our software. Now, binning is used to transform continuous features into categorical features. Any continuous feature like age, salary, distance can be converted into categorical features by creating separate bins. For example, your age can be created into bins for children, adult, senior citizens, and so on. So how we do binning? There are majorly two types: equal width binning and equal frequency binning. Right. So we'll understand both of them. Binning additionally can also help certain architectures like decision trees to split better. So that saves computation, that also increases our understanding about the data. It is easier and more intuitive if you know the bins instead of the complete continuous value. Like, to inject the domain knowledge and to understand more, if you see shirt size or t-shirt size in centimeter or inches a continuous value, you might not get that much information out of the data. But if you create bins for small, medium, large, extra large, that makes it more intuitive for the person to understand. So that way, binning helps us to create bins for the continuous values that can be given categories. Now, equal width binnings create bins that range equally in every interval. So if you have 100 and you create 4 bins, 100 is the range, not the number of values. You will get 0 to 25, 25 to 50, like your age, right? Now, when we talk about equal frequency binning, it is used when there are binning done based on the values, right? It also depends on the domain knowledge, what is your main goal behind the binning. But generally, if your width is fixed and data is normally distributed, then equal width binning can be a better solution. So when we go with equal width binning and I want to create 4 bins out of the age variable, I can just click on apply. So now I have 4 different bins. Similarly, for my credit score, because the range is there, the distribution is not skewed, there are not a lot of outliers, I can simply do equal width binning, which will take equal ranges, equal intervals within my range. Now, when it comes to equal frequency binning, we are now not using the range to divide, but using the number of instances. So when I go into something like monthly income, you can see that data is somewhat skewed. There is an outlier in my data set as displayed in the box plot. In this case, equal frequency binning can give you a better output. Similarly, if you go into transaction amount, you will see data is highly skewed. The tail on the graph, you can see it's skewed to the right, and there are a lot of outliers. In these cases also, equal frequency binning can give you a lot better output as compared to equal width binning. The final decision also is impacted by the domain knowledge, but in case you have a lot of outliers and you go with equal width binning and data is not distributed uniformly, there could be chances that one of the bin is completely empty, one of the bin has a lot more values as compared to other bin. So to avoid this, most cases of having skewed data, people go with equal frequency binning. Similarly, in transaction amount, I will create, let us say, 3 bins for this, and this will make the distribution better and it will create bins. Similarly, customer visit per month is there. It is not very skewly distributed, it is almost a normal distribution. So in that case, equal width can do fine. But again, it depends on domain knowledge, intuition, trial and error can also be used to see how the bins work and how many bins we need to create. Again, using domain knowledge, we can find the answer. Thank you.